right, so remember, a quadratic equation is it's kind of up there, right? A nonlinear equation that can be written in that form. What you guys need to remember is that it's equal to 0, right? And you've already seen equations that are equal to 0 like that. We did that with factoring. You should always try to factor it. Always see if that'll work, okay? Because if you can factor, it's kind of your answer, but you do still have to put a graph on there. And we are looking for where it crosses the x-axis. That is where your solution is. So, number 1, remember guys, we said step number 1 is make sure that it equals 0. Because if it doesn't equal 0, you can't find the solutions, okay? So, with this one, what we did is we subtracted 3 to make it equal 0. So we did this. Then what we did is we got that vertex on there, okay? So first, we found the axis of symmetry, then we found the vertex. Remember, axis of symmetry is negative b over 2a, okay? So in this one, we did negative 2, because that's your b value, over 2 times 1. So we simplified that, noisy people in the hallway, we got negative 1. So that's our axis of symmetry. And this is all stuff from chapter 3 that we did. That's our axis of symmetry. It just kind of helps us understand where our graph goes, where our graph cuts in half. Then once we get your x value, remember you plug it in to get your y value of the vertex. So I keep going equals 0, but that's kind of confusing. So we'll go 1 minus 2 minus 3. 1 minus 2 is negative 1, minus 3 is negative 4. So our vertex is at negative 1, negative 4. So negative 1, negative 4. That's our vertex. Okay, now if I were you guys, I kind of talked about finding other points on the graph first, but if you can get the x values, the answer, the x-intercepts right away, do it, because that's your other point then, and less work to do. So we're going to try to find the zeros first. So we're going to see, does it factor? Because then that tells you the answer, and it gives you 2 other points that you can just graph. So we've got this equation here. So if it factors, that means we can identify 2 numbers that multiply to be negative 3 and add to be 2. What did we say those were, friends? What did we say? Negative 1, right? It was negative 1 and 3. That's what we said, because when we add those together, we get 2. So this one does factor. We can go x minus 1, x plus 3. And then if I do the zero product property and then solve for those x's, then that means I got my other points. So that works. So that's my solutions. And those are 2 other points on the graph. Question?
And you can also guess around and then just reflect it over the axis of symmetry.
What do you mean, guess around?
Well, I looked at the graph. I said, okay, well, that's there. Maybe it's 4 to get to the x-axis. I plugged in 4. I got a 0, and then I just reflected it over the axis of symmetry.
Yeah, you can do that. Absolutely. Remember, the goal here is just to find where it crosses the x-axis. That's it. So if you did it in a different way, that's okay, as long as you're using math and reflection, and sounds like you are. That's good. Yes, I think it's easiest to directly factor, but you know, I'm a huge factoring nerd, so there's that. But what Todd was saying, so if we get, let's say we found 1 point, right? So let's say we could tell real easily where it crosses. Well, this is 2 away from the axis of symmetry, so we go 2 the other way. And there it is, right? You could also plot that y-intercept. We know the y-intercept is which number? -3, so that's another point on there. You could reflect that one. So your job is just to use what you remember from chapter 3, a little bit of factoring. We're just trying to get a graph and see where it crosses the x-axis, because these are your solutions. And I kind of wrote over the solutions part. That's that. Okay, so next one, not equal to 0, right? So we got to get it equal to 0. So we got x squared minus 8x plus 16 equals 0. So we're first going to graph it. Oh, we did that. Step 1, make it equal 0. Step 2, we got to get the axis of symmetry and the vertex. So we're going to go negative 8 over 2 times 1. So we get 4 over 2, which is 2, right? Is that right? Yeah, that's right. Tired, can't think. No, we're good. Okay, so there's our 2. Boop, 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 boop. Okay. So now this axis of symmetry is at 2. Yes, sir. Oh my gosh. See, I knew it was wrong, and you guys were like, yeah, I'm blaming you. No, I'm just kidding. You're right. Thank you. Hour 6, guys. No, I'm just kidding. Okay, 4. There you go. I knew that was wrong. Like I could feel it in my gut. Okay, so that's our axis of symmetry. Okay, now we got to plug it in and get the y value of the vertex. So we're going to plug it in. And you guys remember, what did we get when we plugged it in? We got 16 minus 32 plus, we got 0. Yeah, we got 0 for that. So that's our solution, right? We're only going to have one real solution here, and we'll kind of talk about why that is. But our vertex, we said, was at 4, 0. And that is a y-intercept. And I know that because it's 0, right? And it's also my vertex. So that is my solution. My solution, I would actually say x equals 4 is my solution. But I still need to get a graph on there. So now, since you still have to get another solution on there, easiest thing is, so if your vertex ends up being your solution, let's look at that y-intercept. Oh, and we can't even do that because the y-intercept's like 16. It's too big. So, you know, it's probably easier just to plug a point in and see where you get, right? So I would pick 2, something right next to that vertex, so it's not a really big point. So your third step is just to get the graph. So like, let's try to find when x equals 3, what our value would be. So that means we're going to go to our function and plug a 3 in there. I always try to avoid plugging stuff in as much as I can just because I'm lazy and I don't feel like doing the math. But sometimes you can't really afford to do that. So we've got 9 minus 24 plus 16. Someone tell me what that is. Eitzel, you got a calculator. Can you plug that in? 9 minus 24 plus 16. It's 1?
Yes.
Is that what you got, Eitzel? Hold on. I'm only trusting Eitzel. I'm just kidding. Okay, good. Okay, so that is our point, 3, 1. And then we can just reflect it on the other side. So there's our graph. Then remember, your solution is wherever it touches that x-axis. Okay, now this is going to be what you guys don't have down, right? Next one. Okay, so we're going to get it by graphing. What am I going to do to make that equal 0 first?
Wait,
Add the x squared. Yeah, we don't want to have a negative a value. You can have it that way, but we just don't want to. Okay, so we're going to check if it factors. So we're going to say, does it factor? Oh, wait, sorry, I lied. We're going to get the vertex first. So we're first going to get our axis of symmetry, then we're going to get the vertex. So we got to get negative b over 2a. What is my b value here? 2. What's my a? 1. Oops, bad teacher. Get out of here, Molina Healthcare. I want to talk to you. Silent. Okay. So, what is negative 2 over 2 times 1? Negative 1, that's right. That is my axis of symmetry. Now we got to get the vertex. How do I get the vertex? Plug it in, plug it in. So we're going to go negative 1 squared plus 2 times negative 1 plus 4. Okay, so we've got 1 minus 2 plus 4. What is 1 minus 2 plus 4? 3. So we're going to get a vertex of negative 1, 3. Negative 1, 3. Now here's my question with this one, friends. Okay, which way is our parabola going to face? Is it going to go up? This one's going to go up because that a value is 1. So is this one going to touch or cross the x-axis at all? So that's why this one's going to have no solutions. We still have to get a graph, but it's not going to end up crossing. So since, and we can check it, we can check and see if it factors. You would say no real solution because it's not crossing the x-axis. But mathematically, there still has to be some type of a solution, but we will rectify that later in this chapter and talk about what happens there. But this is the step where we would see, does it factor? And it does not factor because there are no numbers that multiply to be 4 but add to be 2, right? Think about what multiplies to be 4. 4 times 1 or 2 times 2. Those are the only ways. Or negative 2 times 2 times negative 2, negative 4 times negative 1, 2 times 2, 4 times 1. Do any of those add to be 2? No, so it does not factor. Y-intercept, what would the y-intercept be? 4. Y-intercept is 4, so I get that on there, and then I reflect it over. There's my graph. So there's no solution. So we did the y-intercept, which we said was 4.
And I agree with no real solutions is an RS.
For you, Todd, of course. Yes.
That's right.
Any questions? So that leads us, yes, sir.
I don't know if we're going to get into this later, but on the homework, number 9, it's kind of like this, but there's just no b. It's x squared plus 4 equals 0. So would that also be a normal solution?
No, not necessarily. Yeah, that one's kind of weird because that one, actually, when we talk about 4.3 today, you might want to solve that one using 4.3. But I'll show you. I know it's kind of weird for a 4.2 assignment. Okay, let's do the last part. So this last part, we're just kind of summarizing it. So a quadratic equation has, we're going to say 2 real solutions if there are 2 x-intercepts. How many real solutions are there if there's 1 x-intercept, friends? 1. It has 1 real solution if there are 1 x-intercepts. It has no real solutions if there are 0 or no x-intercepts. So wherever it crosses correlates to the real solutions. There are imaginary solutions, my friends. We will see that. Okay, now this one, they want us to find the zeros. Where am I going to look? On the graph. Where on the graph? The x-axis, where it's crossing the x. So what are my solutions here? 3 and -1. And it's totally fine just to write them like that. You don't need to put the point. So you'd say x equals -1, x equals -3. You're going to look at x-axis. Okay? Questions? Okay. Oh, we got to talk about the 0 x, where it crosses the x-axis, right? Where the parabola crosses the x-axis. Does that make sense? Ish. Yes, ma'am?
How is that negative?
That's a +3. Wait. Oh, I wrote it dumb. That was me. I wrote it bad. No, you're right. Thanks, Jade. I looked at my line there. Here, we'll make those arrows. You're right. That is not positive or -3.
Okay, so are we gonna have like 5 minutes to finish up 4x2? Or
Yes, I can give you 5 minutes to take a second and look at your homework. We do have to talk about 4.3 today. I'm sorry. But 4.3 is a great section. You'll love it. You'll love it. And that's it.
4.3.